Hi everyone, good morning. Welcome to Vedantu English. I'm Diksha Kaushal, your chemistry master teacher. So everybody do let me know in the chat box if I'm clearly visible and audible to all of you or not so that we can start with today's session. Yes, students, do let me know everybody in the chat box if I'm clearly visible and audible. And today we are going to do questions from most, like I would say, most scoring chapter, right? Because this is, you know, very predictable questions are asked here, right? And maximum tough questions that they can ask you, I have taken here, right? According to your JEE Mains level, right? And now top 11 question, right, covering all the important topics we are going to discuss today. So it will be a very good revision of your chemical kinetics with the help of question practice, right everybody? So if you're ready, then do let me know in the chat box, right? Okay, so everybody, without wasting any time, let's start with the questions, right? The first question on your screen, that is, for the following reaction, a curve for concentration versus time is given below, right? That is this thing that is given below, as you can see this over here. This is the reaction. Calculate the rate of reaction in the interval of 5 to 15 seconds. That means for 5 seconds, you have to calculate the rate of reaction. For 5 seconds, the concentration is, you can say for time is equals to 5 seconds. The concentration is zero point 0.6. For time is equals to 15. The concentration here is 0.2. 15-second concentration is 0.2. Right? Now they are asking you to calculate the rate of reaction. So what you can do, what is rate, guys? Rate is equals to minus of, right? Or you can just write, if you want to write the concentration, difference in concentration, right? Change in concentration divided by change in time. Now here they have given you the curve of this versus calculate the rate of reaction, right? They have given you concentration of ammonia must be there. So what you will write? You will write minus of, this is final concentration is 0.2 minus 0.6 divided by, this is 15 minus 5, that is 0.4 by 10, right? That will become 0.04, right? So answer is going to be what? 0.04, wait a minute, divided by 10 if rate is given. Okay, so this actually what we have calculated here is, one thing you must know, that this thing is there, that is R is equals to 1 by 2 of DNH2. Now how do I write it in this form? I'll just write it here. How to write rate in this form? Okay, so I'll just write this here. Rate is equals to rate of not appearance disappearance, simple rate of the reaction in terms of ammonia is minus 1 by 2 stoichiometry is divided DNH3 by dt. Whenever there is, you are writing in terms of reactants, then you have minus over there. When you write it in terms of product, you have plus over there. So this will be plus dN2 by dt. And this is in terms of hydrogen, it will be again positive because it is product side, but it will be 1 by 3 dH2 by dt. Now why so this is dH2 by dt? Why this is 1 by 3? Because always in the rate of reaction you divide it with the stoichiometry. In case of reactant it's negative, in case of product it's positive, right? Okay. Now this concentration, this should be mentioned here, that concentration of ammonia is given to you. Concentration of ammonia is given to you, reactant is given to you. Achha, even if it is not given, tell me one thing, the concentration of reactant will decrease, na? Even if you don't know what is this concentration, so this concentration must be for reactant only, that's why it is decreasing. Otherwise for the product the concentration should increase, so it is decreasing, that means it is ammonia only, right? Now all you have to do is you have to pick it here. That will become, as you can see this over here, that will become minus half, as it is final concentration minus initial, final minus initial, that is 15 minus 5, that is 10, right? You can also write this over here, that is 15 minus 5, that is 10. 15 minus 5, solve it, and it's simple, quite simple, you will get your answer. Okay, right everybody? Acha, let's see this question where we are calculating the order of the reaction. Now, to calculate order of the reaction, right, two methods are very famous, right? And first method is this experimental method. Let's talk about this. This is the experiment that we have, right? Now, usually what is written in books and how students solve it is quite different, right? What is written in books, we will not solve it by that method. We will not undergo so many calculations and all. We'll directly solve it how? I'll tell you. But for that, you need to understand one thing. This although we will not do only, right? This all thing we will not do, right? This much though we will not do, right? We will not do all these calculations. I'll give you a direct method, a direct trick to calculate this, and you're totally going to solve all the questions of calculation of order of reaction based on that. So the trick is, I'll just write it here. The trick is that whenever they give you, whenever new rate you have to write in terms of old rate, right, it will be always x raised to power n. What is this x? X is the how many times concentration has increased. Then n is order of reaction with respect to that. I'll apply this thing to solve this question here. I'll apply only this thing to solve the question, okay? Like calculations and all we will not do here. We will directly apply this thing and we will solve the question, okay? All what was written here, we will not do that, right? Now what you have to see, simple thing is, data is given, you will see N2, you will see H2. First you will see that where this reactant is constant. So if you see over here and here, this reactant is constant. And now I'll ignore this part. This part I'll ignore as of now. When I am looking at these two things, I'll ignore the third part. That is this one part I'll ignore. When this is constant, I'll see what is the change that is there in concentration of H2 and rate. This will be, I'll be calculating the order with respect to H2 here. With respect to H2, because H2 is the variable here. So H2 is how many times? This seems to be 4 times here. So H2 is multiplying 4 times. Okay, so concentration is increasing 4 times. And rate is increasing 4 times again, right? Rate is also increasing 4 times again. So you can write here that rate nu is equals to 4 times of rate old, because rate is increasing 4 times. Also, rate nu is equals to 4 raised to power n of this. Ma'am, how do you write it? This I have written it like this. X raised to power r of old. And what is x here? It is also increasing 4 times. This is x. This is x raised to power n, right? So that is the thing. So this is 4 raised to power n r naught. So it is clearly seen. If I want to make these two things same, if I want to make this thing and this thing same, what I will do? It should be 4 raised to power 1 is equals to this. That means I can clearly see order of the reaction with respect to H2. I'll just NH2 I'll write, that is going to be 1. Okay. Now I'll change it. Now I'll do the opposite here. Now I'll see where H2 is constant and this is variating, right? H2 is constant here, H2 is not changing here, and here this is variating 3 times. This is multiplied by 3 times, okay? And here this one is getting multiplied by how many times? 3 into 3, 3 times. So simple. So we can see this over here. Even with B2, it is order with respect to NO. So you can see this over here. New rate is equals to 3 times of old rate, and new rate is equals to 3 raised to power n times of old rate. That means we can say n with respect to NO is also 1. So overall order of this reaction is going to be 1 plus 1, that is 2. Okay, that's how you're going to calculate this, right? Okay, yes, order is 2. Very good, right? Okay, tell me, is that clear? Simple, right? Now based on this, they can say sometimes, for example, it is written this is increasing, I'm just assuming one thing, this is increasing let's say 4 times, and this is increasing how many times? Let's say this is increasing 16 times. So what it will be? Rate mu is equals to 16 of rate old. Rate nu is equals to 4 raised to power n of rate old. That means n is equals to 2. Okay, that's how you solve these questions. Okay, right? So this is all you have to apply, even if they have given you A is doubled, rate is then this. So that is a simpler version of this experimental data. Here you have to see whether it is doubled or what, then it is directly given in the question, but the way you solve it is exactly the same, right? Okay, now let's see the next question here. That is a zero order reaction, right? You have very good, Sabrinath, very good. Uh, Array, first method is not wrong. It's not wrong, it's that calculation is required there. Firstly, you will calculate the value of rate constant, then you will, it's like lengthy. So in the exam, we have to save our time, right? So it's better to solve it this way, right? Okay, yes. Ma'am, how 1 came? Array, 3 raised to power 1. This is 3 raised to power 1. These two things should be equal. That is means n is equals to 1, na? How can 3 raised to power 3 is equals to 3 raised to power n? Only when n is equals to 1. Right? Okay. Chal. Now let's see. What do I explain? Okay, chal, I'll do that. See, just remember that whenever it is written, rate of new is equals to x times n, x raised to power n rate of old, right? You will just see here how it is variating. When this is constant, this is 4 times, this is also 4 times, right? So I have written it here that this is 4 times, that is rate is 4 times, and in terms of concentration, it is x raised to power n, that is 4 raised to power n, so n is coming out to be 1. Similarly, with respect to NO, when I make this as constant, this one is constant, then this is changing 3 times and this is changing 3 times. So even here, what the rate is, here 3 raised to power 1, this is 3 raised to power n, so n is going to be 1. Okay, right? Okay, understood? Yes. Shall I move ahead now? Tell me. Shall I move ahead? Right? Tell me, guys, was it difficult? Was it difficult? I thought you will like find it quite easy. What's difficult in this? I don't understand. What do I tell you? That how 4 raised to power n is equals to 4, then n is equals to 1. Tell me one thing. When I say 4 raised to power n is equals to 4, then obviously n will be 1 here. Oops. See, because of you, this whole thing is done, right? So I'll have to eventually write it again. How many of you literally said, ma'am, please solve it again? Right? How many of you literally said, ma'am, please solve it again? Huh? See, guys, simple thing is, I'll just write it fast here. R of new is equals to x raised to power n of R of old, right? Just remember this thing here and we will solve it here. right? Okay. Now, if you see this thing over here, with respect to H2, we know that R of nu is coming out to be 4 of R of old, and R of nu is also equals to 4 raised to power n of R of old. So that means R with respect to H2 is going to be 1. Similarly, with respect to order, with respect to NO is going to be R of N is how many times? 3 times R of old. And here R of N is also concentration. How many times concentration is changing of NO? Raised per N of RO. That means here also this order with respect to NO is going to be 1. Okay. This is also order with respect to NO. Right. So this order is this. So overall order is going to be 2 here. Right. Okay. Tell me. Ma'am, undo it. Don't write. I tried undoing it, but it was not possible. ठीक है ना बेटा? Understood? If I say, अच्छा, tell me one thing. Tell me, I want to like know whether you're able to understand, because I can't see it in the chat box if you understand this or not. Tell me one thing. If in some case rate is increasing, how many times? 9 times. And concentration is increasing 3 times. What is the rate here? What is the rate here? What is the order here? Same thing you will do. What is the order here? You will say rate of nu is equals to 9 times rate of old, right? Also rate of nu is equals to, this is x time n rate of old. X is nothing but 3 raised to power n rate of old. So that means 3 raised to power n has to be equals to 9. That means n should be equals to 2. Isn't it? Got it? How order is 3? How? Do you say 3 raised to power 3 is 9? No. 3 raised to power 2 is 9. This is what I am telling you. One time you write directly how rate is varying. Then write it in the form of concentration. Concentration raised to power n. Right? It's a very simple trick, guys. Right? This is concentration. If you're not able to understand this trick, then simply solve the value of k, but that's a very lengthy method. I will never recommend the students to do it. Right? So simply this is x. X is what? X is the change in concentration. How many times concentration is changing? That I have written 3. 3 raised to power, what is 9? 2 is 9, na? So answer will be 2. Okay? So understand this. Don't do silly mistakes in the exam. This is quite a simple question. Right? Now let's talk about this question, that is, a zero order reaction is 20% completed in 10 minutes. At what time it will be 80% completed? So here what they have given you, they have given you two ways. 20% completed. Whenever it is in percentage, always take A naught is equals to 100. And 80, 20% completed means 100 minus 20, that means 80 will be left behind. Okay? Always when percentage is given, initial is going to be 100 here. Right? Now, if you see what is the formula, formula is going to be 80 equals to A naught minus KT. This is for zero order reaction. So I'll just write here 80 is equals to A naught minus of KT. Now everything is given to me. 80 is given to me, that is 80, and this is 100. This is minus of K, and this is given to me 10 minutes. Right, so I'll just solve it here. This will be 10K, that is 100 minus 80, that is 20, right? And this is K is equals to this, so answer will be 2. K is going to be 2. Now again we are saying after 80% completion, what will be there? After 80%, A naught is 100. 80 is 100 minus 80, that is 20. Right, so I'll apply the same method here. 80 is equals to A naught minus of KT. 80 is what? That is 20. Right, A naught is 100. This is minus of K. What is the value of K? That is given to be 2. And time you have to calculate, will calculate it in per minute only, a minute only. So we'll say this is 2t, and this is 100 minus 20 is 80. So time is going to be 80 by 2, that is nothing but 40 minutes. So answer is going to be 40 minutes is the correct answer here. Right? Okay? Yes. Right, everybody? Acha. Now let's see this question, that was zero order reaction. So the formula that you applied was different. Here it is a first order reaction. So most probably either zero or first order reaction they will ask. An organic compound undergoes first order decomposition. The time taken for its decomposition. Now understand one thing. Whenever it is given in percentage, you will take initial concentration as 100. Whenever things are given in fraction, you will take initial concentration as 1. Right? So they are saying the time taken for its decomposition, 2. 2 means 80 is going to be 1 by 8. If they say this much is consumed, then I would have subtracted it from 1. Reduced 2, decomposed 2 means final concentration is 1 by 8. Right? Here you will take for time, this is for how much time? Initial concentration is this respectively. So what this is A naught is equals to 1. This is A T is equals to 1 by 10. Right? And this is a first order reaction. They are asking you what is the value of this. Now, what is the formula? The formula is T is equals to 2.303 by K log of, see, K will be same because it is the same reaction that is undergoing. So K is going to be same. This is also constant. This is log of initial concentration is 1, final is 1 by 8. So it is going to be this. So here you can write that this we are talking about, this is 1 by 8, T 1 by 8. And here this is T 1 by 10, that is nothing but this is 2.303 divided by K. This is going to be log, initial concentration is 1, final is 1 by 10. So here what you will do, they are asking you the value of division of both multiplied by 10. So what you will do here, T of 1 by 8 divided by T of 1 by 10 multiplied by 10. Okay, what is that? So this is 2.303 by K log of 2 cube. What is 8? That is nothing but 2 cube. This is 2.303 by K, and log of 10 is 1 only, isn't it? Log of 10 is 1 only. So you can say, and this will come in front, so this will become 3 of log 2, and this will become log of 10, that is 1 only, and this whole is multiplied by 10, right? This is given in the question that you have to multiply this thing with 10. So I'm just multiplying this with 10 here, and log of 2 is given to be 0.3 here. So this is 3 into 0.3 into 10, that is nothing but that is going to be 9. So answer is going to be, what is the value? The value is going to be 9 here. Okay, right? Solve it and you will get your answer there. Next question is, a rate constant of a reaction at two temperatures are given to you. Calculate the activation energy. Now this is based on Arrhenius equation, and from Arrhenius equation, that is K is equals to A e raised to power minus EA by RT. Right? When you solve this with K1 and K2, taking log here on both sides, then the formula that you get is this one. And this is a very important formula. Right? It's a very important formula. Log K2 by K1, this is activation energy 2.303 R 1 by T2 minus 1 by T1. 1 by T1 minus 1 by T2. Now here if you see, the value of this is in degrees Celsius, this in degrees Celsius, right? And the rate constant, let's say this is K1 and this is K2. That is given. So first you will calculate this in Kelvin, right? Then only will put the values, right? So you'll calculate this in Kelvins and then only you will put the values here, right? So if you see 227 plus 273, that is going to be 7 plus this is 0, 7 this 0, this is 2 plus 5, right? And here it is 427, then again 273 Kelvin, this is again 7, 10, 4, 5, 6, 7, 700, right? Always these values has to be put in kelvins, okay, right? Okay, always put these values in Kelvin, right? This will be in Kelvin, that will be in Kelvin. Our rate constant K1 and K2 is given. Calculate the activation energy of the reaction, right? So now we know that K2, K1 is given, T1, T2 is given. What is the value of R here? Because see, here we are talking about energy. Whenever we are talking about joules, energies, then we calculate, we put the value of R as 8.314. If you remember in solution chapter, I have put it in 0.0821. Whenever things are in pressure, volume, we put it 0.0821, right? And here 8.314, you can write it as 25 by 3 to make the calculation easy for you, right? Just to make the calculation easy, you can write it in fraction as well, right? So put it all the values here and you will get the value of activation energy here, because you're putting it in joules, so that's why energy will also be in joules. If they have given you it in electron volt or they have given you it in kilojoules, then you will have to do the conversion, okay? Just remember that what is given in the units, right? Because in these questions our unit tends to be more important here. Next question, if you see guys, that is solve the correct statements. Now four statements are given to you and one of them is like correct, okay? One of them more are correct, okay? More are correct here. When temperature tends to infinity or EA 0, then K is equals to A. Let's verify whether it's true or not. We know that K is equals to A e raised to power minus EA by RT. Guys, now understand one thing. If this is infinity, if something is divided by infinity, then it will be 0. Then that means this whole value will be 0, right? E raised to power 0 is nothing but that has a value 1. So that means e raised to power 0 is 1. That means what you will say, K is equals to A in that case. So which is definitely correct here. So E is definitely the correct statement here, right? Second statement is a positive catalyst can change delta H of the reaction. Now in chemical kinetics, we have this catalyst, what it does, right? Catalyst only changes the activation energy. I'll just show you this with the help of a diagram as well. If you see, this is, let's say, initial, this is final. After the catalyst is there, it will only change the activation energy. It is not going to change this initial initial heat, and that means the heat of the reactant and product will not be changed here. We know that delta H does not, it is from thermodynamics, we know that it is not a path function, it's a state function. It only depends upon the final and initial state. So it only depends upon the heat of product and heat of reactant, which is not changed by the catalyst. Then how can it change the delta H? So it changes only the activation energy. It does not change the delta H of the reaction, right? So this statement is absolutely not correct, right? Let's see the third statement here. That is a mixture of reactants may be thermodynamic unstable but kinetically stable. So we are saying mixture of reactants may be thermodynamically unstable and kinetically stable. So are there any reactants which are thermodynamically unstable and kinetically stable? That means thermodynamically they are going to take place, but kinetically they are not going to take place. So two things are there, thermodynamically and kinetically. Kinetically means the rate of the reaction is favoring it, it will take place. And thermodynamically means it is a spontaneous process and that is why it will take place. So there are reactions which are thermodynamically unstable and kinetically stable, like you have rusting of iron. This is one of the famous example which is thermodynamically it will take place, so that's why it is unstable thermodynamically, but kinetically this reaction will not take place, right? So that is also the correct statement. So this is correct, this is correct. Last is a negative catalyst increases the activation energy of the reaction. Definitely. A positive catalyst will decrease the barrier and will make it easy. A negative catalyst, like you have poison, if you remember in PdSO4, PD and H2, that we do hydrogenation, we use BaSO4 Lindlar's catalyst to convert uh, alkyne to cis alkene. Why? Because we don't want it to get converted to alkene. That is a negative catalyst. That is acting as a negative catalyst, right? Like that is making the process slow, right? So negative catalyst increases the activation energy and makes the reaction difficult. That is also absolutely correct. So we have what statements are correct? We can say statement A, C, and D are the correct statement. You know how they can ask you the question in the exam, right? They can ask you how many statements are correct in the integer type of question. So you can write 3 statements are correct. They can ask you, that's why I am not asking you the way they will ask you in the exam, right? So things may variate. They may ask you how many statements and you will write 3 statements. They may ask you option A is, let's say first option is A, B, C. Second option is A, C, D. Third option is A. And fourth option is D, right? So what is the correct answer? So accordingly it can variate, right, the way they ask you the question, right? Yes. Now next is for a hypothetical question. Now this is very interesting one. This is an interesting question. You will have fun doing this question. Okay, so let's do this. Let's do this question, everybody. For a hypothetical reaction, so basically instead of taking a simple question for you which is dA by dt, because see in first order reaction they will not see I it will be stupid of me if I give you unnecessarily tough question even if they are not asked. So based on first order reaction, Arrhenius equation, right, maximum that level they will go. But because this is a very easy topic, right, that is rate of disappearance and appearance, it is quite an easy topic. They can also ask you an easy question based on that, but what if they ask you tough? Then it would be this kind of category. Okay, so let's talk about that. So here it is. You have these two reactions. They are saying delta H of this reaction is -2. This is X. This is -2X. That is plus X. Okay. These reactions are carried simultaneously. The temperature is not changing. If they're reacting simultaneously, right, on this at the same time they are reacting, temperature is not changing. Can you tell me what they want to say here? That's a very important thing. If the temperature is not changing, that means the delta H here, this and this is actually the same. The delta H here is same, right? So overall heat of the reaction is same. The temperature change is not there. Overall heat of the reaction is same. So you can write this like this. Wait a minute. I'll just okay. So one thing, that means we can say since the temperature is not changing, the net delta H for the process should be 0. Delta H of the process should be 0. Now how do I write the delta H of the process here? Right, let's write it over here. That is going to be, I'll just tell you that how to do it, okay? What do you have to write here? Just write the value of E, and this is on the basis of M here, right? So you can write it like this. Delta H, let's say this is delta H1, let's say this is delta H2, because two reactions are given. Delta H1 mod, and you write it here. This is going to be, what is the disappearance here? That is minus dA by dt, right? And this is delta H2 mod, right? And this is in terms of M, it is minus dm by dt. Okay, so this is all what you have to write here. Acha. Once it is done, then what is given to you? The rate of disappearance is given to be y. That means disappearance is minus dB by dt. Now, whenever you write rate of appearance, disappearance, you never divide it with the stoichiometry. Remember, rate of reaction is divided by stoichiometry. Appearance, disappearance is never divided by stoichiometry. So, you'll write it minus dB by dt is equals to y. That is given in the question. So, in terms of y, you have to answer it. Now, somehow I have to calculate the rate of the formation. That means I want to calculate the rate of dq by dt. You know how I will calculate? Firstly, what I'll do from this reaction, tell me how Q and M are related. I'll write that rate of reaction of this second reaction is equals to minus dm by dt, that is rate of disappearance of M. Stoichiometry is 1 because right now I'm writing rate of reaction, so I'll divide it with the stoichiometry. So here it will be plus 1 by 2. So you can just simply write 1 by 2. This is dq by dt. Right? So that means all I have to do is I can say dq by dt, that is what is asked in the question, that is 2 times minus dm by dt. Now you just have to calculate the value of dm by dt. Acha, remember one thing. dm by dt is given here. But that you can calculate if you know the value of minus dA by dt. So now I'll calculate the value of minus dA by dt from here. Right? Remember that rate of 1 is equals to, this is minus dA by dt, that is equals to, this is 1 by 3 minus dB by dt. Acha, now tell me one thing. What is minus dB by dt? This is given in the question, that is y. So this is 1 by 3y, isn't it? So you can write this, this is nothing but y by 3. Now tell me if that is clear, how do I write it? Right? Yes, Vishwanath, yes, welcome. Tell me. This is rate of this reaction. I wrote it in terms of A and B here. B value is given to me in the question. So I write the value of D minus dA by dt, that is y by 3 it is coming out to be. Right? Okay. Now, if I put this y by 3 value here, right? Now, if I put this y by 3 value here, what I'll get? Tell me everybody. If I put this y by 3 value here, what I'll get? This is delta H of 1 is given to be minus of 2x. So you will put it here minus of 2x. This is minus dA by dt. I have calculated it to be y by 3. So I'll put it here y by 3. This is delta H2 is given to be x here. This is minus dm by dt. Right? Now, if you see this x and this x will cancel out. So it will be 2y by 3 is equals to minus dm by dt. Right? You have the value of 2y by 3 here. You have the value of minus dm by dt. Once you know the value of minus dm by dt, you put it here. Right? So you can write it here that dq by dt, this is what they are asking you, that is minus of, this is given to be 2y by 3. Minus of, now why I am writing minus here? Right? Minus you will not write, this will be 2. This will be simply 2 into, or you can just, right, this will be 2 into 2y by 3, that is coming by 4y by 3. Okay, so it's a very good use of, easily students can do silly mistakes in this question because there is so many things you put here and there, right? Because two simultaneous reactions are given to you, right? When two simultaneous reactions are given to you, this is how you solve it. Right, so answer is going to be C is the correct answer here. Right, everybody got it now? Two simultaneous equation. I have written the rate of reaction of both of them. Then hint was given to me that this temperature is not changing, and that's how I calculated that here its heat net change should be 0 here, right? Okay, and that's how we have this, right, everybody? So that's it. This is what you have, right? Achha. Now let's do the next question, that is this one. This question is, what amount of reactant for first order reaction will be left after 3.5 minutes? Now they are saying that what amount of reactant would be left for first order reaction would be left after 3.5 minutes. Graph is given to you. Okay. What you can do here is ln of AT and T. We know ln of A0 minus ln of AT. This is the way we write. Acha ma'am, how do you write it? Arey simple yaar, 2.303 log of A0 by AT. If it is not log, it will become ln of A0 by AT. ln of A0 by AT is nothing but ln of A2 minus ln of AT. Isn't it? ln of A0 minus ln of AT. Isn't it? Now what you have, what amount of reactant for the first order reaction will be left after this? Now if you see this here, slope, because you know angle is given to you, and we know that slope is equals to tan theta. Now some students will do this mistake, they will directly write theta as 45 degrees Celsius, right? But that is not there. If you put this line like this, okay, this is the theta that you have. This is the theta that you have. So theta is this value, not this value, it is this value. The slope that we are talking about, this is theta, okay? This is theta. And theta is nothing but that is 180 degree minus 45 degree, and that will be 180 minus 135, right? 135 degree it will be. So you have to now tan 35 you have to solve. So trigonometry you will use here, right? Acha, ma'am, how do I compare? Ma'am, how do I calculate the value of what amount of reactant for first order? I am calculating the value of rate constant firstly from here. So I know that ln of AT is equals to minus of KT plus ln of A0. So if I compare this with y is equals to mx plus c, then m is coming out to be minus of k. That is nothing but that is tan 135. So you will solve it. You will solve the value of k from here. You will solve the value of k from here. And then they have given you what amount of reactant for the first order reaction will be left after this. You just have to put this value over here. That is k is given, time is given to you. So you can say k into t is equals to 2.303 log of initial value, what amount of reactant is left. So what you will see, what amount of reactant left means they are not asking you, they are asking the value of AT here, right? So A0 you can take it as 100, right? Then you will calculate the value of 18 percentage. Then this 80 will be in percentage. How much percentage is there? If you put it in 1, if you put, let's say if you put it 1, then this will be in fraction. Then 80 will be in fraction. Okay? I'll say that calculate this in percentage only, and that's how you will do it. K value you will calculate here. Time value it is given to you. That is time is 3.5 minutes, right? Then you will calculate the value of 80 from there. Tell me guys, is that clear? Now it's all calculations here. You will solve the value of k. Tan 135 is minus 1, so k is going to be 1 here, right? Then we know that this is another way actually. Okay, this way also you can calculate. This way is also is good. In fact, this is a better way, right? This is a better way because in the end, here what will happen? You will have to take anti-log here. So that Can be, it's not like this is a not, here you will calculate it wrong. This is also right, but here you will have to take anti-log. So that is a, in fact, better method. Achha, for this 2-3 formulas you must know. The formula is, first formula that you should know is T half is equals to 0.693 by K, right? Once you have calculated the value of K, right, then you will have to solve this for first order reaction. This is valid. Then another thing is number. This N is the this is not order of the reaction. This is number of half life. Number of half life. Okay. So number of half life is total time by T half, right? So you can say total time is equals to number of half lives into T half. So what you can calculate the number of half lives here, and also remember that this particular thing is also like quite famous here. Always remember that in terms of number of half lives, AT by A naught is equals to 1 by 2 of raised to power n, right? So you have calculated the value of n from here, that is 5. You put it here, right? And you will get the value of AT by A naught, right? Just solve it like this, okay? AT by A naught, that is 1 by 2 raised to power 5. That is 1 by 32. So AT is equals to A naught by 32. So that means how much time it is decreasing? It is decreasing by 32 times, right? Okay. So this is an easy way to calculate this. Just remember this N is the number, or they can also ask you directly from the question, what is the total time? What if they ask you the total time? What if they don't give you the total time? They give you reverse. They give you the value of A naught. They give you the value of AT. Then they ask you the total time. How do you calculate? A naught and AT, 1 by 2 A naught by AT, this is 1 by 2 raised to power n. You will calculate the value of n here, that is number of half lives. N multiplied by T half is the total time. Okay, this T is nothing, this is the total time. Total time. This is half life. This is number of half lives, right? Okay, yes. Acha, now let's do this question. How many? I think some three, 4 questions, 2-3 questions we are left with. Let's 2-3 questions we are left with. Let's do that. Now this question is also a different question, right? But they can ask you this kind of question in the exam. For the system, this and this system is given, which was started with only A. So it was started with A. The equilibrium concentration of A equilibrium is correctly related to B and C as what? Now equilibrium concentration they are asking you. You will find it because it is given in the rate constant form. So how do you find it? How do you write it? You will write the value of this concentrations, right, in the form of K1 into A. This is K minus 1 into B. This will be K2 into A. This is C into K minus 2. So that's how you will write it. So basically, you will write the value of how much rate is there, that is minus dA by dt, that is equals to K1 into A, K minus 1 into B, and this will be subtracted forward minus backward, right? Then this is from the first reaction. From the second reaction, you will say K2 into A, this is K minus 2 into C. Forward minus backward again, right? Once you know this, now see one thing, that at equilibrium, overall rate is constant. That means minus dA by dt. This is the rate of the reaction. That is going to be 0 here. So we can say at equilibrium, this value is 0. Now you just have to put all the values. That means this whole value is 0. Then what you have to do is solve this equation. What they are asking you to solve the value of A equilibrium. A equilibrium is this. You have to solve this value. So take A equilibrium as common. This will be K1 plus K2. And this you can put it on the right hand side. positive, positive, right? So K A equilibrium is equals to this divided by K1 plus K2. Okay, so that was, but still here it was important what we have done on this step. After this, so it's easy only that you just have to put this rate is 0 because it's a constant, it is at equilibrium. After this, it's simple maths. How do you calculate? This is all maths. This is all maths. This is not chemistry. Till here, it is chemistry. After this, it's maths only. Right? Okay? Understood? But this point is important for you. This point is important that when two reactions are given to you that are simultaneously reacting, then that's how in the form of equilibrium you write the values. Right? Okay? Understood? Now this question here, that is, for a first order gaseous reaction, the total pressure after time t was Pt and after a long time it was P infinity. The rate constant is given by what? Let's understand this question, everybody. Let's understand this question. So what is given to you? They have given you A gas, B and C. Acha. A give rise to B plus C. See one thing here. Initially it is P naught. This is 0. This is 0. At time t it will be P naught minus x into stoichiometry. This is x and this is x. Okay. What if there was 2? Then it would have been 2x. If it was 3, it would have been 3x. If here it would have been 2, it would be P naught minus 2x. According to the reaction, this will change. Now at time infinity, this whole of this will be reacted. This will be P naught into stoichiometry. This will be P naught into stoichiometry. Now see this. This is at time is equals to 0. This is time is equals to t. This is time is equals to infinity. Now how do I answer this question? See, I know that the value of k is equals to 2.303 divided by t log of initial concentration, that is P naught, divided by the final concentration at time t, that is P naught minus x. So this is actually the value here. But can I say nowhere it is given in the terms of P naught and x? That means I have to replace the value of P naught, I have to replace the value of x here, right? So this is what I'll have to do, and they have given me it in the form of either P naught and P infinity and Pt. And what is Pt given to you? That is the total pressure at time t, and P infinity is total pressure at time infinity. That means I can say P naught minus x plus x plus x is given to be Pt in the question. That is P naught plus x is going to be Pt. Also, what is given next here? Also, P infinity is given to be P naught plus P naught. This is P infinity. So 2 of P naught is equals to P infinity. So I can replace P naught is equal in terms of infinity is P naught by P infinity by 2. Here if I see what is the value of x here, because x also I don't want in the question. So it will be Pt minus P naught. P naught is given to be P infinity by 2. So tell me what is the value of Px here? What is the value of P naught minus x? P naught is P infinity by 2. X is Pt minus P infinity by 2. That will become P infinity by 2 minus Pt plus P infinity by 2. That is P infinity minus Pt. This is the value of P naught minus x. So I'll now put these two values here. So what you have here, 2.303 by t, this is log of P naught is P infinity by 2. And what is P naught minus x? P naught minus x is P infinity minus Pt. So I'll just put it here, P infinity minus Pt. And if you see P infinity by P infinity minus Pt, B is the correct answer here. Right, everybody? Tell me, everyone in the chat box. I think students have gone. They had their schools, huh? Oh, last question, those who have gone, right? Please see this last two questions, okay? This is quite important. Chalo. I'll just put it here, right? Let's see this last question, guys, that we have. Let's see this last question that we have, right? Last question that we have. Okay. So if you talk about this thing, fatapat se will do it. Firstly, how do you solve this question here? This question is given to you. First, you will see the rate determining step, that is the slowest step. Rate determining step is this. According to the rate determining step, it is going to be k of a raised to power 1 and b2 raised to power 1. That is going to be the rate determining step, right? And here it is given to be k2, right? According to the rate determining step. That is the first equation. Now, the intermediate will never be there in the rate law equation, so you have to replace the intermediate here. Intermediate, that means out of this A and B2, which is not there in the overall reaction, A is not there in the overall reaction, so this is the intermediate. So here you will calculate the value of intermediate from the fast reaction, that is Kc is equals to product, that is A square, by reactant, that is A2. So you can say from here you can say that A is equals to Kc under root and this is A2 under root, right? This is the second equation. You will put it in first, so it will become R is equals to K2 into Kc raised to power 1 by 2. This A is what? This is nothing but A2 raised to power 1 by 2. This is B2. Now, if you see the overall, let's say there is no new rate constant, that is K dash. So it is A2 raised to power 1 by 2. This is B2. So with respect to A, it is half order, that is 0.5. With respect to B2, it is 1. So overall order of the reaction is 1.5. Got it? Intermediate will never be there. First you will calculate rate law equation, rate law expression from slowest step, but intermediate you will have to replace from the equilibrium, right? Okay. Yes, everybody, tell me in the chat box. Right? Right, everybody? Yes, in fact, you are right. It can also be this. Huh? It can also be C. I'll then change it. I'll change it. I think by mistake it is written P naught then. Because it must be in terms of P naught and P infinity only. Right? So if you see, the answer is going to be 1.5 is the correct answer, and that's it for today. Now I'll take your leave, but before going, students, just remember that here you will see ask with any doubts. Just click on this and you will get to this particular portal. And if you see this over here, right, wait a minute, this is the replay of this not replay, actually you can see it on YouTube as well. Here what you will get is you will get all the doubts that you have regarding this particular lecture. You can ask your doubts here, you can ask for PDF here, you can have quizzes here based on this lecture. Everything that you need, be it notes, be it doubts, be it quizzes, everything will be there, right? Over here it will be written doubts, likes and comments, and go to there and you will get to your portal where you have all the quizzes and doubts and PDF notes. Everything will be there, right? All you have to do is just click over here, right? Okay, so that's it, guys. Now I'll see you all in the next class. Till then, bye bye, take care. I'll see you all at 6 p.m. where I'll be doing aldehyde ketones and carboxylic acid in one shot. We'll complete the chapter in detail. It is going to be 7 hours marathon. So I would say join in, and don't be like, ma'am, how much time. It is going to take time to complete a chapter in detail, and it is definitely going to give you a lot of marks. So everybody, see you all today at 6 p.m. Till then, bye bye.